So for this next problem, there are three parts to it. The problem states that Mrs. Hinojosa had 75 feet of ribbon. If each of the 18 students in her class gets an equal length of ribbon, how long will each piece be? And the three parts are: write your answer using only feet, using a whole number of feet and a whole number of inches, and using only inches. So this problem kind of scaffolds students' thinking because it starts out asking them to simply find the answer in feet. Then it goes from feet to feet and inches, and then lastly just to inches, and it challenges students a little further. So to start out with what we know, or what they told us, what is given, she has 75 feet of ribbon, the teacher. And then it says that she's going to be giving her 18 students in her class equal length of this ribbon. And students have to understand or make the connection that this means they'll be dividing, or how it relates to the operation of division, because she's giving this ribbon out. She's splitting it up between the students. So they're going to have to make that connection that she's dividing this length of ribbon by 18 students. So for the first part, where it asks to find the length of each piece using only feet, you're simply dividing the number of feet by the number of students to find out how long each piece is for each student. There are multiple ways that this could be done. This could be done through drawing out a picture, which obviously couldn't draw actually a 75-foot ribbon, but you could draw a smaller model of it and divide it by 18 to figure it out that way. Or if resources were available, you could use actual ribbon, which that visualization could really help a lot of students and have them physically divide the ribbon up. Another way that this could be done is through the standard algorithm of just dividing, which is what I'm going to show. So there's 75 feet of ribbon divided by 18. I'm gonna try 18 times 3, 24, 54, too low, 18 times 4. This is just guessing and checking. 32, 4, 5, 6, 7, 72. So 18 times 4 is 72. So what a lot of students are going to want to do here is just have 4 feet remainder 3. But this is a good opportunity to teach students about having the fraction piece that is left over, or decimals, from a problem. So what you could do here to find the fraction that's left over, this remainder is the numerator, and what you're dividing by, the 18 students, is your denominator. So you would have 4 and 3/18 feet, but this could be simplified even further by dividing both the top and the numerator and the denominator by 3 to get 4 and 1/6 feet as your answer for this problem. And then, so for the second part, where it asks to find the answer in feet and inches, you already know that it's 4 feet, but you need to convert this fraction of feet here into inches to find out how many inches that 1/6 would be. I personally am going to figure this out through drawing, just because fractions is more difficult for me, and it's better for me to see it visually. But you could also figure this out through proportions or through algebra, whatever way makes sense to you and for the students. So I'm gonna draw out a foot, or a model of a whole foot. And I'm going to split it up into sixths because I have a 1/6 fraction here. Sixth. And then I'm going to draw another foot where I break it up into 12ths because there are 12 inches in every foot. One, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, if this was drawn more to scale, you would see that 2/12 or 2 inches is equal to 1/6. You could also figure this out by just using equivalent fractions because you know that an inch is 1/12 of a foot and 2/12 is equivalent to the 1/6 fraction of a foot that is up here. So you have 2 inches left over in your ribbon. You have 4 feet, 2 inches that each student gets. That's how long each piece is. And then for the last question, where it's saying, or it's asking for you to give the length in solely inches, what you need to do, or what the only thing left that students need to do, is convert the feet into inches and add it to the inches that they already have. So here they need to know the conversion factor between feet to inches, which they should already know from figuring out part 2. So there's 12 inches for every foot. And if you have 4 feet, you're going to need to, and you multiply this side by 4, you're going to need to multiply this side by 4. You could also do this again through different methods, through drawings, or through an algebraic equation or something else like that. This proportion just makes more sense to me. So there's 48 inches in 4 feet. So if you have 48 inches in that 4 feet, but then you also have these 2 inches left over, you need to add those 2 inches back to it for a total of 50 inches. So there it is.